All right, good morning. I hope the test went well. Just a reminder about the test. If there's any questions that you have, your scratch paper has to show correct work. So I'm going to be real strict about that. So the online exams are easier than what I would give in class. And so just make sure that you're showing correct work. Don't assume that I can interpret your garbage. So I'm just letting you know. The solutions should be written in a solution set. Extraneous solutions should be written as X not equal to something. And so I'm not just guessing, you know what you're doing. So because Mr. Johnston, the AP Calculus teacher, and him and I are both the AP pre-cal, we're very strict about notation. So I know some of the teachers at the lower levels aren't that strict about vocabulary notation, but we are, because there's a it's just like the English language. Your teachers would get after you if you put a period at the beginning of a sentence and put a capital at the end of a sentence. So just like the English language, and your teachers are strict about the way you write the language, mathematics has a language, and I expect you to be able to use the correct vocabulary and to be able to write your math correctly. All right. Okay. So today, what we're going to do is we're going to kind of go backwards. In the next two lessons are things we've already done. So in lesson 10.2 is graphing square roots, and lesson 10.3 is graphing cube roots. Well, we've already done that. And so what we're going to do today is I'm just going to talk about a couple things. I'm going to put you in the Math Wizard teams, and I'm going to give you a practice on just graphing cube roots and square roots. I'm using transformations. Okay. Also, if you have friends in period 3, I have not taught this lesson yet. So the lessons are going to be switched. And so just pay attention to what's going on in period 4. All right. Okay. So let's take a look at lesson 10.2, which is graphing square roots. Okay, this is California Common Core Standard F-IF.7b. Okay, and I'm going to pin myself so I can see what you guys are seeing. Let's see if I can get this here. All right, here we go. Okay. So the first thing I want to talk about are the two forms. So I've talked about the forms a lot, but I'm going to do it again. And I'm going to show you the square root. So here's form 1. And this will be form 2. So form 1 for square roots is a times the square root of bx minus h plus k. So this is no different than the quadratic, except for the fact that instead of a square, you have a square root. And then form 2 is a times the square root of b, and sometimes you see it as 1 over b. Regardless, you know it's the reciprocal, the horizontal stretch of compression, parentheses, x minus h plus k is outside. So that is nothing new. And I'm going to write down the order here. So I'll just tell you, the order makes a difference when you have a B and an H. And when you're working with rational functions, it actually changes the asymptote. So you got it. Sometimes the order doesn't matter, if you've noticed, but sometimes it does matter. And I'm telling you, it matters when there's a B and an H other than 1 or 0. All right, so the order for the first one is your left, right, your stretches and compressions, your reflections, and then your up and down translations. When you have the second form, the order is your stretches and compressions first. Then your reflections. And then this is where your left-right comes into play, and the up-down is always last. All right, so I'll do a graph and then we'll see how many questions you have about it. I really doubt if you're going to have questions, but we'll see. So I'm going to do something with 3 transformations. So this is going to be g of x is equal to 2 times the square root of x minus 3 minus 2. Now, I'm not sure what you're doing, but you want to make sure that you write the transformation in the correct order. You want to show the transformational points and graph. Now, these online tests, if you're not showing the transformational points, you're on a slippery slope. So you want to make sure you're doing what I'm telling you to do. Otherwise, you're going to have a lot of trouble later on with the trig functions and everything else. So you want to make sure that you're doing those 3 things. Okay, so what is the first of all, this is form 1, right? And what would the order be? Got him listening?
Right.
It'd be right 3, a vertical stretch by 2, and down 2. All right, what are the points for square root? Are they the quadratic points, or what are the points for square root? And if you don't remember, you can easily just put them into the parent and give me 2 points. So if you put in a 0, what's the square root of 0?
0.
0.
If you put in a 1, what's the square root of 1?
1.
And you know you can't have a negative 1, right? Because you can't have a negative under a square root, right? Right. So you're going to use these 2 points, 0, 0, right 1, up 1. You should know that square root goes off to the right. So square root looks like that. If you don't, look at the list of parents that I gave on the sheet a long time ago, the parent functions. So now right 3 means 3, 0. Right 3 would be 4, 0. Okay, now vertical stretch would be the y. So when you vertically stretch the y by 2, that's a 0. Multiply 2. And then you have down 2. So the x's stay the same, and down 2 would be a negative 2, and down 2 would be 0. You guys okay or no? If you're not okay, speak up, because I'm assuming you already know how to do this. So when you graph these points, it'd be 0, down 2. It'd be right 1, 0. And all you did was move let's see what happened here. We move right 3, then we did a vertical stretch by 2. This should be a 3, right? So notice I knew that my graph wasn't right because we're shifting right 3 and the graph doesn't look like it was shifted right 3. So it's right 3, down 2, and then what's the next one? We didn't reflect, so it shouldn't be going backwards. So where's the mistake? Right 3, vertical, oh, it's right here, 4. I'm writing a bunch of weird numbers. Down 2. So is it 4, 0? That looks better. Then you go off to the right. Is that right now or no? Yes, no?
Yes.
Right 3, vertical stretch by 2. This should be, let's do it again. So 0, 0, trying to rush this because I don't want to teach it. Right 3 means the y stays the same. So right 3 would be 3, right 3 would be 4. Vertical stretch means the x stays the same. So that'd be 3, 4, vertical stretch multiply by 2, multiply by 2. Down means the y, so the x stays the same. So down 2 would be a negative 2, and down 2 for this one would be 0. So right 3 down 2, 4, 0, that's correct. All right, what would the domain be? Go ahead, I'm listening. What's the domain?
It's from 3 to infinity.
3 to infinity, good. And what's the range?
From -2 to infinity.
Negative 2 up forever. So this is right 3 to infinity, and the range is down to negative 2, up forever. So that would be your domain range. You will be required to do that today. Okay, any questions about this? All right, now, in lesson 10.3, we're going to be talking about cube roots. And you should know how to do those. So I'm going to do a problem. Kind of looks like that one, but it's not. It's the cube root of x minus 3, which is the inverse of the cubic. State the transformation. The transformation would be, this is the first form, right 3. Vertical stretch by 2 and up 5. Now, what the parent looks like this. So what are his points? Well, you can have a negative under the radical now. You can have a negative under an odd index. So what's the cube root of negative 1? Negative 1. What's the cube root of 0? 0. What's the cube root of 1?
1.
1. So take the points. Left 1, down 1. 0, 0. Right 1, up 1. You guys, I was thinking I would get a cubic over here. This is not, these aren't inverses. This is the cube root is the inverse of the cubic, x cubed. The inverse of the square root is the parabola restricted. Okay, so let me just say it again because I don't know what I said before. Okay, so the inverse of the square root is the parabola restricted, and the inverse of the cube root is the cubic, the snake that goes up and down. This guy does not go up and down. He goes left and right. All right. So when you do a right 3 would be a 2, right 3 would be a 3 and a 4. The y stays the same. Vertical stretch means the y. So the x's stay the same. And we multiply the y by 2. Multiply the y by 2, multiply the y by 2, and then finally up 5 means add 5 to the y, so the x's stay the same. So add 5 would be 3, add 5 would be 7. So when you go to graph these, you're graphing right 2 up 3. You're graphing right 4 up 7. And you're graphing right 3 up 5. So do not draw a line. You want to draw the snake sideways because the cube root. So this goes off to the right and that goes off to the left. What's the domain? Forever left and right. What's the range? Forever up and down, just like the cubic. Remember the cubic, the domain and range would switch. So the domain for the cubic and the domain for the cube root is forever left and right, and the range is forever up and down. Okay, anybody have any questions? All right, let me ask you then. Who are the points? Who are the parent points for the square root?
0, 0, and 1, 1.
Yes, it goes off to the right. Who are the parent points for the cube root?
-1, -1, 0, 0, and 1, 1.
Yeah, that's correct. Okay, so here's what you're going to do. You're going to go into your Math Wizard teams, and there's an assignment that looks like this. It says, using the parent as a guide, state the transformation, show the transformational points, graph, then state the domain and range. And if you notice, I mixed up the problems here. So some are square roots and some are cube roots. So this is pretty much your final opportunity to get this straightened out. So make sure that you collaborate in your group. If you have any questions about everything, make sure you're talking through the points and make sure that you know exactly what you're doing, because I'm not going to be doing this again. All right. You should know you should know the order, and you should know how to get the transformational points perfectly, in addition to graphing and getting the domain and range. All right. So we're going to be working till 10:45, which is almost an hour. So there's no excuse for not getting this. So if you're somebody who's confused about something, make sure you call me in there, or make sure you ask somebody in your group, because I want it all cleared up to date with everyone. Okay? All right. I will see. And by the way, just a reminder, if you're not showing your face in the teams, I'm making phone calls home. I want to know from the parents and guardians what's going on. Because in the big session, you may not show your face because of the internet issues, but there shouldn't be any internet issues with the small teams. So I'm just letting you know, I talked to a bunch of technical people. There should be no problems with showing your face in the teams. Redlands Unified, everyone has to show their face every day. If they don't show their face, they get marked absent. I wish we would have done that. So I'm just letting you know that I am making phone calls, and I've already started doing that. So make sure you show your face if you don't want a phone call home. Okay? All right. I'll see you in your teams.
Are we going to be coming back?
Good question. We will come back because I want to make sure there's no issues that I need to give to the class. Thank you so much for stopping me. Okay, so class is over at what, 10:45? So we'll be back at 10:35. So we will report back at 10:35 just to make sure there's no major issues. Okay, I'll see you in your teams. Okay, we're back, hopefully. All right. Well, the groups were fairly quiet at first. It might be because they're new groups, I don't know, but you guys need to listen carefully to me, okay? You're going to have to talk in your life. You're going to be working on projects out, in the professional world. You're going to be working in teams. You have to be able to explain things to people so that they understand, because you have a piece of the project, they have a piece of the project. You have to be able to collaborate and work together. And you may not want to talk. You may not even like the people in your group when you're out in the real world. But you're going to have to be able to do this, because just being smart is not going to fly when you're out in the real world. I'm telling you. So I want to make sure you don't have this false notion that just because you're bright, that everything's going to be okay. You have to be able to talk. All right. So I think I shared with most of the groups that the number one complaint of kids being hired out of college is that they cannot communicate. So that's the number one complaint. So we have to practice talking. You may feel uncomfortable, but you've got to get past it. And it's better that you learn this now rather than later and get fired from a job because, yeah, you're smart, but nobody understands what you're doing or saying because you're not talking. So we have to get better at it. We've got to practice. The other thing is you can't be afraid of making a mistake. We learn from our mistakes. That's why we're collaborating, so that we can fix each other's mistakes in a positive way. So don't be afraid to make mistakes. And those of you who are leaders, if you're getting frustrated with your group, welcome to real life, because you're going to be frustrated a lot. So this is just what you have to deal with. So we've got to be able to get better at collaborating so that you're able to transition into real life better. Okay? So when we are in these teams, I don't even really care about the math so much. What I care about is, can you talk math? Can you communicate what you're trying to get across? And so those of you who are trying to talk, perfect, because you will get better and better. If you don't practice though, it's not going to come automatically. Trust me, I've worked with mathematicians and I've worked with computer scientists that can't talk. Nobody understands what they're doing. Nobody can figure out what's going on, and it's very frustrating. So we got to keep practicing and getting better. All right, now, would anyone like me to work a problem?
I don't have a problem, but I have a question.
Yeah.
So let's say for like the interval notation with the parentheses and there's a 0, would that be open or closed parentheses?
If it's square root, it's closed.
Okay.
So whenever you have infinities, they have to be open. But on square root, it's going to be like on number 1, it's closed on, the domain is closed on -3 to infinity, and the range is closed on -2 to infinity.
Okay, thank you.
Okay, anybody want me to work a problem? Because I want to show you what I do.
Can you do 11?
All right, let's look at 11. And I'm going to show you what I do. Oh, actually, on that one, it won't. Okay, I'll work 11. All right, 11 is what? K of x is equal to the square root of 3x plus 3. So I expect you all to be able to read these. So you want to practice reading. All right, so this is a horizontal compression by 1/3 and up 3. So square root is 0, 0, right 1, up 1. And a horizontal means x. So multiply the x by 1/3 and multiply the x by 1/3. The y does not change. And when you're working in these groups, you should read off those points to make sure everybody concurs. Okay, then we're going up 3. So up 3 would be a 3, up 3 would be a 4. So when you go to graph these, I always draw a picture to show what I'm graphing. I'm graphing square root, and it's not being reflected or anything. So we're going 0 up 3, and we're going right 1 out of 3 parts up 4. So my domain is closed on 0 to infinity, and my range is closed on 3 up forever. Do you guys agree with me or not? All right, I do want to work another problem to show you what I do. So I didn't get to show it on this one because there was no reflection. I want to do a problem with reflection. So give me another problem.
12 has reflection.
6 also.
Student number 6. Now these answers, you guys, I put my answers in the answer documents. So I have all the answers in the answer documents. All right, so g of x is equal to 1/2 times the cube root of negative x. So state the transformation in the correct, okay, so this is what I do. The cube root, I always draw the picture. What's the transformation in the correct order? Go ahead, I'm listening. There is no left, right. So what's next? Stretches and compressions. So it's a vertical compression by 1/2. Now what?
Reflect over the y.
Okay, now watch what I do. Since it's a reflection over the y, I come back to my little picture and I reflect it over the y. So it should look like that. Right? If I reflect it over the y, actually, this is better, watch. Okay, watch. The cube root looks like this. When I reflect it over the y, it should look like that, right? So this is the graph I'm going to do. And I always draw a little sketch just so I don't mess it up. So if it was a reflection over the x, I would show the reflection over the x down here. So it was a reflection over the y, so I always draw a picture to know what I'm going toward. So now the cube root is left 1, down 1, 0, 0, right 1, up 1. So what are your points for a vertical compression? You multiply the y, right? So what do you get? Go ahead, I'm listening. What points do you get when you do a vertical compression by 1/2?
-1 and -1/2.
Yep. Go ahead, 0, 0. Right 1, up 1/2. Yes? So now you reflect y, which means negate the x. So negate the x, negate the x, negate the x. So what are your points now? Somebody read them off. Go ahead, somebody read off the points. What are they?
It's -1/2, 1, 1, -1/2, and then 0, 0.
-1, up 1/2, 0, 0, right 1, down 1/2, right? So right 1, down 1/2, 0, 0, left 1, up 1/2, and now I drew this little picture to remind myself that it should look like this, right? So you have this going like that, and you have that going like that. What's the domain? Negative infinity to infinity. What's the range? Forever, up and down. All right, well, hopefully, I'm hoping you're working together outside of class. Pay attention to the order, and I will see you guys tomorrow. So I'll see you Wednesday. All right, have a good day.
Miss Birch,
Yeah,
you want to talk about the test?
can't, I have to teach a class in about 4 minutes.
Oh.
So you have to send me a reminder, and we can set something up later. But I'm not going to be available till like after 5 today. I'm booked. I got meetings and everything, so I'm going to be busy for a while.
Don't worry about it.
Okay.
All right. See you then.